So now we're going to start on a different project. You guys have watched me build these batteries enough that I don't feel that we really need to worry about it. How we build it. The number one question I get with is charging. Well, as you can see, we're sitting at 14 point something volts, and we're just going to ramp this up to its max. Let's see here. So we got an RSP 1500-15. It's variable up to about 17.5 volts. Well, right now it's putting 88 amps worth of charge into these batteries. There's two batteries there. There's two banks of 6. Battery A, battery B. The chemistry of this battery lends itself to some amazing phenomenons. Amazing in the sense that it can handle as much current as you can possibly give it as a charge. And it'll also let go of as much current as you can put upon it as a load. The resistance of the battery is such that it is lower than the resistance of, let's say, a power supply. So the confusion lies in the realm of charging. Your stock alternator in your vehicle will charge a lithium battery just fine. But there are some things that you have to be made aware of. We're putting almost 100 amps worth of current into the battery, and look at how slowly that voltage is coming up. This freaking thing is a sponge. We're going to be here a while. We're going to charge this to 16 volts and then we'll shut it down. If you choose to use a stock alternator to charge your electrical system or charge your lithium battery in your vehicle, understand the fact that if you have this battery in your vehicle and you choose to run it down to very depleted, 13.5, 12.5 volts, you also have to understand in your mind that if you let your vehicle run at an idle to charge this battery, it will overheat your alternator and cause it to burn up. But if you sit there in your vehicle after you have your battery completely depleted down to the 12.5 volt range, if you simply just run the throttle up from 500 idle RPMs to 1,000 RPMs, you'll be fine. All alternators are cooled the same way. Some alternators have the plate externally, some of them have them internally, but there's a plate that spins. It's got little fins on it. The fins move, create a low pressure, and they either push or pull air through the enclosure of the alternator to cool it. Alternators are horribly inefficient. They can only produce, let's say you have a 200 amp alternator on your truck. It's producing 200 amps worth of DC power, but it's also creating 200 amps worth of heat. At idle, alternators, most of them, cannot adequately cool themselves with this particular battery bank attached to it if the battery bank is very heavily depleted. Now, I want to show you what happens when we get towards the top end of the charge cycle. Okay. Let's go ahead and let's unplug. Holy moly, oh moly, that little 110 plug is hot. I'm sure the positive and negative wire, yep, they're hot too. We've just pulled a solid 100 amps through this thing for however long I've been talking. I want to show you something. This is really neat. And this is the reason that we can get away with using stock alternators to charge our systems or charge our lithium banks. But it's all in how you run it. So now what we've done is we've disconnected the power supply and we had our voltage set at 17.76. Well, it was going to push 17.5 volts until one of two things happened. The power supply exploded the battery explode, or we popped a breaker. So let's dial this into something that's a little bit more sensible, so I can show you what our cutoff voltage is. Okay, so we're going to set this at 15.82. Well, instead of us pushing to 17 volts, we're already right below that 15.82 voltage. Okay, charging up the capacitors inside the power supply. It might be time to redo my power wires coming off the power supply and my 110 plug, and I've had the same charger, or the same power supply now for yet a decade. I've used it to jumpstart multiple vehicles. It's the shop hussy. It gets around, right? Okay. Let's make sure everything is good and tight. Good and tight, they say. 14.85. Go ahead and we'll turn this all the way off. Bring it back up to DC. We'll turn the light on so you guys can enjoy it. We're going to zero it. And let's plug it back in. Now we're pushing 88 amps per hour, right? Let's watch what happens when we get closer to the 15.82 and our amp draw. So like I was saying, if your alternator is a 200 amp alternator and you decide that you're going to run your battery down to where it's really heavily depleted, and watch, look at our current drop. As our voltage increases, same phenomenon will take place in your vehicle. If you fully deplete the battery down to like 12.5, your alternator's in there screaming underneath the hood. So how you compensate for that is you simply stand on the throttle the first couple minutes that you're charging your battery up and give your alternator and give the battery a chance to get recharged and get full of energy. We set the power supply at 15.82. Now let's look at the amount of current. It is dropping. We're not changing anything. But this is the coolest bit of it. Let's say you have your voltage on your alternator set at 15 volts. In this situation, we're setting it for 15.82. That's a realistic voltage for a 16 volt battery. When we achieve fully charged, and the last couple amps take the longest to get there, because now we're stacking electrons just gradually. When the battery is fully charged, it's not presenting any load to the alternator, and the alternator is sitting there free spinning, and it's cooling itself completely off. So when it is presented with a load, the alternator is at its full resting cool temperature. It's not hot, unlike in a lead acid system where there's a load constantly present. Constantly present. Lead acid chemistry lends itself to the point where you got to push it over 2 volts. Lithium technology, where you set the battery's resting voltage with your alternator, is where it's going to be charged to. You'll come out the next morning, turn your key on, the voltage is going to be the same thing unless there's a parasitic draw depleting the battery overnight. So we went from pulling 89 amps down to 7 amps, and we got 0.2 of a volt to go. You can totally charge a lithium battery off your stock electrical system in your vehicle, but it's only going to charge it at like 14.2, 14.5 volts. And that's when you get to go learn about external voltage regulators, external voltage rectifiers, if you want to go past that 14.5. Or having a third, what they call the 3-wire setup on your alternator, where you've got an external voltage regulator and a MOSFET that controls the switching of the. So we're pushing 4.6 amps in to get 1 more tenth of a volt over here, which this might click up. But once we eventually get to fully charged, this drops to 0, presenting 0 electrical load to your system in your vehicle. 0. Remember, only charging to 14.2, this battery is totally capable of doing 16 volts and maintaining 16 volts. Like I said, that last tenth of a volt is going to take a minute. This is the time when I normally shut the lights off. I'll go have dinner or give it a couple hours for the thing to just sit here. And what's happening is each one of the cells, because none of these have ever been charged, we're at 1.1 amps now. All the cells are balancing themselves out slowly. Like, you got to think of each one of these as like water tanks, and there's a little bit of air bubbles in each one of the tanks. And we're just slowly cycling water through the tanks, and the air bubbles are and we're filling up to our maximum. This takes a long, protracted amount of time, but eventually this will drop down to like 0.2 of a volt or 0.2 of an amp. And that means the battery is at its fullest potential that it can be. And we got to do this with every single new battery that we get. Just give it time. It takes a little bit of time the first charge, but then after that it is rock and roll, mama, daddy, let's go. So we'll go ahead, we'll cut the mic off again. We'll jump into some fast forwarding time frame here, and we'll see what happens. Well, this meter gets a little flaky underneath an amp. We're at 0.4 of an amp. We're at 15.83. So 15.82. It takes a while, doesn't it? But it's charged. And now it can dump out 900 to 1,000 amps worth of draw like that. Of course, the laws of thermodynamics and Ohm's law and yibbity schmibbity being what they are, if you pull 1,000 amp load on this, you're going to have to replace the 1,000 amp load with a little bit of charge over time, right? But the amount of storage that's in this bank is breathtaking. Let's see where we sit tomorrow morning. We'll let this sit here and just do nothing for the next 10 hours. Well, good morning. It's actually like noon my time. So these sat all night long. We charged to 15.82. See, where'd we end up? 15.6. So we lost 0.2 of a volt in roughly 14 hours. And it's not too bad. Well, this battery bank is for a friend of mine. And we're building this for Bullet Bob. This is gonna go in his new ride-around truck, other than his Escalade. So, that note, we're going to wait for the next steps. But I'm going to release this as its own individual YouTube video where we talk about charging and show charging and that kind of thing. So you guys are watching that. If not, stay tuned. If this is in a later video, stay tuned and we'll show you the rest of the beautiful construction for this little battery. So, gentlemen, we'll see you. Click, click.